So we have seen that force on particle 2 due to 1 is this given by this, and force on particle 1 due to 2 charge 2 is given by this, and both these are forces equal in magnitude but opposite in direction. So this is mentioned here, R21 is equal to R12, but there must be a negative sign. There is a mistake here, so there must be a negative sign. Thus the Coulomb's law agree with Newton's third law. Then all of you know that there must be equal and opposite forces. So this Coulomb's law also agrees with the Newton's third law. So let us move further. So now this equation 1.3. This is equation 1.3 gives the force between two charges Q1 and Q2 when in vacuum. In vacuum, if the charges are placed in a matter or intervening space has matter. Suppose if we put another material there, then the situation gets complicated due to the presence of charge constituents of matter. So this is not that simple. We will understand later why. So we shall consider electrostatics in matter in next chapters. In next chapter we will see that what will happen when there is a matter placed between two charges, okay, two different kind of charges. So now there is an example, Coulomb's law for electrostatic force between two point charges and Newton's law for gravitational force between two stationary point masses. Both have inverse square dependence, okay, you know both are proportional to 1 by r square. The distance between them and charges and masses respectively, you know. Okay, compare the strength of these forces by determining the ratio of their magnitudes. So this is important question. Last year you have read in the first chapter that what is the ratio between electrostatic force and gravitational force, and you are well aware that gravitational forces are quite weak forces, but here you are going to calculate that. So now for an electron and proton, so there are three cases given when two particles are, and first particle is an electron, another particle is proton. Two protons, both the particles are protons. So there are two particles, one particle is electron and another is proton. That means a condition of an atom. Condition of an atom. So in an atom, very simple atom, hydrogen atom, the proton is there and electron is revolving around this. Another case is two protons. If you see the nucleus, a heavier nucleus than hydrogen atom, so there are protons as well as neutrons. So different type of protons and neutrons live inside that. So if you see the helium nucleus, there are two protons, and these protons live in a very small area of 10 to power minus 15 meter. So estimate the acceleration of electron and proton due to this electrical force of their mutual attraction when they are 1 angstrom apart. Okay, so second part is that we have to calculate the acceleration. If you know that force, then mass is known to you, you can calculate the acceleration of electron and proton due to the electrical force of their mutual attraction when they are 1 angstrom. Please again note down what is the definition of 1 angstrom. That is 10 to power minus 10 meter. It is not 10 to power minus 9 or 6. It is 10 to power minus 10 meter. And mass of proton is given like this, and mass of electron is given here. So these are also very important quantity, and you will go these quantities again and again throughout this book. So note it down. Mass of proton is 1.67 into 10 to power minus 27 kilogram, and mass of electron is 9.11. Just leave this one, 9.1 into 10 to power minus 31 kilograms. Okay, so let us solve the part 1. The electrostatic force between an electron and a proton. So this time we are taking an electron and a proton, and distance is r. Okay, So force on electron due to proton, so it will remain same, only the direction will change. So 1 upon 4 pi epsilon naught, this is a constant. Both proton and electron have the charges E, so the charge is E into E, so that is E square, but electron has a negative charge, so there comes a negative sign, and the distance between them is R. Okay, so this is there. So where the negative sign indicates that the force is attractive, that you know that the force between a positive and a negative charge must be attractive, and if both the charges are positive or both the charges are negative, then it must be repulsive, that you know. So negative sign always indicates that the force is attractive. If there is a positive sign, that means force is repulsive. The corresponding gravitational force. So now let us calculate the gravitational force. Gravitational force, this is electrostatic force and this is gravitational. The gravitational constant, mass of proton, mass of electron and distance between them, square of them. So let us divide electrostatic force upon gravitational force. So again we have taken mod, so just by taking mod we know that the minus sign cancel out. Also, why there is a minus here? The minus here represents that the gravitational force is always attractive force. It does not depend on the type of matter or type of particle. It is always an attractive force. So when we calculate, so this thing, when we divide, so this comes out E square upon 1 upon 4 pi epsilon naught G MP ME. So when you put all this value, the value of E is 1.6 into 10 to power minus 19 to power whole square. You know what is epsilon naught, you know what is G, mass of proton and mass of electron are given here. When you solve, and you should solve, try to solve this, you get this number 2.4 into 10 to power 39, which is a huge number, very big number. That means the electrostatic forces are 10 to power 39 times stronger than gravitational forces. On similar lines, the ratio of magnitudes of electric force to the gravitational force for two protons. Similarly, we calculate again this E square comes 1 upon 4 pi epsilon square also come, epsilon naught comes, this G MP and another, instead of ME we have another ME. This comes because mass of proton is quite high. See, mass of proton is quite high in comparison to mass of electron. So mass of proton is nearly 1836 times higher than mass of electron. So this is reduced, this force is reduced, but still between two protons the electrostatic force is 10 to the power 36 times of this gravitational force. So again we have seen it is quite high. Last year we just discussed, this time we have seen how it is quite high. So we have seen this. So however, it may be mentioned that the signs of two forces are different. This is positive, that means repulsive. That for two protons the gravitational force is attractive in nature, always attractive in nature, and the Coulomb force is repulsive. The actual values of these forces between two protons inside a nucleus, as we discussed, two protons could only be there inside nucleus. The distance between protons is 10 to power minus 15 meter, which is the diameter of this nucleus. See, this electrostatic force is 230 Newton for very small protons, whereas gravitational force is quite low. So here you can see that 230 Newton for two small protons in this small radius. Now you can understand how powerful this force is.